For this second example, we have our function with the first and second derivative, so we don't have to do it. And we have to find the intervals where it's increasing and decreasing, and the x-coordinates of any max or min. And we have to also find the intervals of upward or downward concavity on the graph, which determine the x-coordinate of any point of inflection. So we are going to start with the point A. We have to take our first derivative. We already have it, and we have to equal that to 0. We have to see when the function is going to be 0, like what value has to be x to be the function 0. So in this case, I'm going to take the 216 times x, and then I have to equal that to 0, and 0 over 216 is going to be 0, which means x is our critical number. And because the denominator is times 2, always is gonna be positive, so that means x doesn't exist. So we have those two x, and we have to do our first numerical line, which goes from minus infinity to infinity, but we have to plug our critical numbers there. So in this case, it's just gonna be 0, and then we have to pick a number between minus infinity to 0, which I'm gonna do -2, but you can do whatever you want, and then another one from 0 to infinity, and in this case I'm just gonna put 2. So after that, we have to take our first derivative again, and we have to change that x for the numbers that we picked on the numerical line. So as I told you, I'm gonna choose -2 and 2. Which means 216 times -2, that we don't care about the number right now, so we only need the signs. So in this case, positive and negative is going to be negative, and then the denominator is going to be positive. So which means it's going to be negative over positive, which we are going to have negative. This means that part of the graphic is decreasing from minus negative to 0. And then we have to do the same thing, but with the number 2. So we have the first derivative, and we change the x for 2, and then we are going to do the same thing. We don't care about the number, so we need just the sign. So 216 times 2 is going to be positive, and then the denominator is going to be positive as well, which means it's increasing from 0 to infinity. So we have to write those arrows, which is going to show us that part of the graphic is decreasing and the other part is increasing. And we can see that we have a minimum point on 0. So because we know that we have to equal, we know that the function is going to be equal to y, our y point, and then we have to change our function, the first one, with the number 0, because that's the critical number that we found. So we are going to do 0 over 0 plus 2, which means it's 0 as well. So that means that our min, it's going to be 0, 0. That's our point. Now we are going to do the point B. We have to take, for in this case, the second derivative. We already have it as well, so we are just going to write it, and then we have to equal that to 0 again. We have to do the same thing as the first time. We need to know when the function is going to be 0, x, what value has to have to be 0. So in this case, because it's already like factored, we know that x minus 3 equal to 0 is going to be 3, and then x plus 3 equal to 0 is going to be minus 3. So that's our 2 critical points, and we know the denominator is going to be always positive because x is over 2. So we have x, it's equal to 3, x equal to minus 3, and x doesn't exist because of the denominator. So we have to write our numerical line again, but in this case we have 2 critical numbers. So we have minus 3 and 3. So we have to write again from minus infinity to infinity, but we have to write those critical numbers. And then we have to choose any number that we want from those parts. In this case, I'm gonna pick -4 for the part of minus infinity to -3. I'm gonna pick 0 to -3 to the power -3 to 3, and then I'm gonna pick 4 from the part to 3 to infinity. After we finish picking our numbers, we have to use the second derivative and plug that number in on the axis. So we don't care about the number, so we just care about this sign. So because the first part is negative, negative, and negative. That means it's gonna be negative, and then the denominator is gonna be positive. So that means that part is gonna be concave down from the minus infinity to -3. And then we have to do the same thing with 0 and 4, as I'm showing you here. For the second derivative, when we replace the x for 0, we have minus, minus, and positive on the numerator. So that means we have a positive number, which means it's gonna be concave up from -3 to 8. And then we have to do the same thing for the last one. So then this number is 4, and we have minus, positive, and positive, which means it's gonna be positive, and the concave is gonna be down from 3 to infinity. So I wrote like the concaves on the behind the numerical line, so I can see the graph how is how is doing. And then I can see that the first one is down, the second one is up, and the third one is down, and I have two points of inflection, which in this case are -3 and 3. And then after that, we just need to take our first function and replace those, like that function, that x on the function, we have to replace it with the points on inflections. So I'm gonna start with 3, and then that is gonna be 1, and then I did it the same thing but with -3, because that was those ones were our point on inflection, and that gives me 1, so it's there equal.